about dew point? Dew point is perhaps the next most common parameter. And dew point we know about again from probably the weather report, unless you deal with it every day. So in the weather here in the San Francisco, San Jose area, do they report dew point? No? Some places do, some don't. Many times if there's a heavy agricultural base, they'll report dew point, mostly because of the fall, because of frost danger. But dew point, what is it? Well, there's a couple of definitions. One of them is it's the temperature at which a moist gas is saturated with respect to a plane surface of pure liquid water. Or another definition is it's the temperature to which a given portion of air must be cooled at a constant pressure and constant water vapor content before saturation occurs. So what we say we wanted to know the dew point in this room. There's some clues already on what we know the dew point has to be at least above. Anyone know what that clue is? Exactly. Our water pitchers. So we see on our water pitchers that we've got condensation. So what that tells us is that the dew point is above probably 33, 34 degrees. Because what happens is when the air in this room gets to a certain point, when it gets to that saturation curve, that's your temperatures are the same. Your dew point is the same as your air temperature. You'll get condensation. So it's a good one to describe to get your kids working on, if you got kids. You get them around the dinner table and say you've got some condensation on their ice water or whatever they're drinking. They're probably not drinking Moosehead. But and in some places we give the seminar, there's no condensation because it's drier. Places like Denver or Phoenix or Dallas, places like that, there's no condensation. So what happens here is that you've got your glass, and if the dew point of the air is 20 degrees, which we know it's not here, but if it were 20 degrees, you put a 38-degree beverage in there, you're not going to get any condensation because the air around this glass is not below the dew point. But like we're seeing here today, we have a dew point of 45. We put a 38-degree liquid in there. Now the air around this glass is below 45 degrees. So we will get condensation. So do we have a dew point instrument back there, Ricky? What is it? 58 degrees. It's fairly humid. So as long as we put a liquid in here that was 58 degrees or cooler, we get the condensation. If we look at it mathematically, this is a conversion formula. If we're going to convert dew point for different pressures, and you can see the active variable here is only PW. These are derived constants based on the temperature range. So Tn, M, and A are all derived. PW is the variable. So what that tells us is that dew point does not change with temperature. Dew point only changes with pressure. So no matter what we change the temperature to in this room, the dew point would always be 58 degrees. But pressure changes will affect dew point. And this could be important if you're looking, and we'll talk about this later, but if your instrument's outputting dew point, but your sensor's measuring RH, you know that pressure will affect it because pressure affects RH. So you've got to know what your sensor's measuring too. But if you have a pure dew point instrument like a chilled mirror, doesn't matter what the pressure is, you'll have consistent dew point. Yes?
I have one of your instruments here.
Yep. Mm-hmm.
It doesn't measure the pressure. How does it calculate the actual point?
Well, the dew point's calculated by RH and T. Right. And then we calculate it from there. Yeah. Yeah, so, yeah. Does that answer? Okay. Okay, rule of thumb for dew point and pressure. As your pressure increases, your dew point temperature rises. Air becomes more moist. You approach saturation. As your pressure decreases, your dew point temperature gets lower, and it gets farther away from your air temperature, so you get drier. Questions or comments on dew point so far? Then we have this term called frost point. And frost point is, you don't hear it as much, but it is significant in some cases. So frost point is the temperature at which a moist gas is saturated with respect to a pure surface of pure ice. And it's because the partial pressures are a little bit different over water than they are over ice. So if you're below 32 degrees F, you're going to have a difference between a true dew point and a frost point because of that difference. If you look at it on a table, you can see that as the drier you get, or the lower the dew point, the bigger the difference between frost point and dew point. So if you have a minus 40 degree, say minus 40 dew point on your compressed air system, you should know if you're reading dew point or frost point, what your instrument is outputting. So 3 degrees, 3.5 degrees difference, do you really care on a compressed air system? Probably not. But if, say, you're in a research lab and you've got two, say, chilled mirror hygrometers, and their accuracy is plus or minus 0.2 of a degree C, and one's giving you dew point and one's giving you frost point, now you have a 3.5 degree difference between two precision instruments. Now you want to know, which one is my instrument measuring? And a chilled mirror, by the way, you can get dew point below 32 degrees if it's a really pure system, because then you have supercooled water. So you should know one way or another if your mirror has ice on it or water on it. So it could be significant. Yes?
Chilled mirror, you mentioned a chilled mirror has water there?
Yep. A chilled mirror?
Yeah, so you just try to get competition. Yeah.
No, the question was about basically how a chilled mirror works. Yeah, you've got a mirror, and you've got a light reflecting off the mirror, and then you cool down the mirror gradually until you get condensation. And when you get condensation, if it's cold enough, like if it's below 32, that condensation can be water or it can be ice. And yeah, it diffracts the light, tells you what the temperature is, but you need to know whether it's ice or water to know if you're getting a dew point or a frost point.
Yeah, but you just mentioned it's only water.
No, it can be either.
Oh, it can be.
It can be, yeah, it can be ice or water below 32. Yeah. Okay. In Vaisala instruments like the HM70 we just mentioned, you'll see either TD, which gives you a true dew point across the entire range, or you'll see a TDF, which means you have dew point above 32 degrees and frost point below. But you should know, the point here is, you should know what your instrument is giving you. If it just says dew point, it's a good practice to know, am I getting a true dew point or am I getting a frost point below 32? What am I getting? So you should inquire about that if it's not made obvious by the manufacturer. Dew point examples, electronics testing. There was a company I visited in Phoenix, and big electronics manufacturer, and they had a contract with, I think, the Army or the Air Force, one of those agencies, and it was to test the electronics for some kind of highly expensive project. So they brought in this prototype test, they put it in a chamber to test it for temperature, and they started bringing the temperature down, and they got the temperature down to a certain point, and all of a sudden there was condensation in the chamber on this expensive electronic device. And the condensation ruined the device. So this company's on the hook for, I think they told me, $1.2 million because they ruined this device. So in that case, what they would do, and what they did after that incident, they would measure the temperature in the chamber, and they'd measure the dew point. And if for any time they got within 10 degrees of each other, as they approached, they would shut down the test. So they would bring in nitrogen into the system to make sure it stayed dry, but they monitored it by measuring dew point versus temperature. This is pretty common in electronics testing. And then, of course, compressed air systems. This is a big centrifugal compressor made by Atlas Copco. Electronics, manufacturing, clean rooms, same thing. You measure the dew point and the temperature, and there has to be a certain difference there. Questions or comments on dew point? Okay. Oh, yeah, it's all right.
If you go back to your table, the dew point work is this one.
Yeah.
So how do you measure a dew point like at negative 96 degrees C?
How do you measure dew point at minus 96?
It's hard already.
Well, yeah, if you brought it down to saturation, certainly it would freeze. Yeah. But you can...
So will that be a frost point? Is that dew point?
Theoretically, could you get a dew point at that temperature? I doubt it. They have to be extremely tightly controlled. Typically, I think you can get in this range here, -5, -10, is where you can get the supercooled water.
The difference is it's not that big area.
Not big anyways, yeah. Yeah, this shows illustrates the point. Yeah. Good point though, yeah. It's tough to get down a -90 degree dew point. It's tough to measure it.